We are going to start an interesting topic, right? That is called extension, right? So imagine this. Imagine this before getting into content of this particular slide. Imagine you have, let's say, a support and you have a spring, right? It's empty right now. This is the original length of the spring, L. Now, what do? You add a weight over here, right? So what happens? You add a weight and this spring becomes what? It stretches, right? Let's say this is a block A. So actually this was the original length of the spring, right? Now it is basically as follows, right? So the spring has extended by an extension that is E, right? So if I applied a force that was of the weight which I attached with the spring, the spring was extended by an extension that is called E. Okay. So basically 300 years ago, right? Approximately 3 centuries ago, this experiment was done by Robert Hooke, right? An experiment by Robert Hooke. Does anyone know who was Robert Hooke? Has anyone watched a video or watched this documentary वगैरह or this experiment
Sir,
we do? Yeah.
I learned in school about Hooke's law.
Does anyone know about Robert Hooke? You know, I'm gonna tell you about Hooke's law. Does anyone know who was Robert Hooke? Okay, so he was an experimental physicist, right? So we have two types of physicists, right? So we have physicist over here. It has two types. One are theoretical. One type is theoretical, and the other type is experimentalist, right? Experimental, right? So इस कैटेगरी में आता है आइंस्टाइन, स्टीफन हॉकिंग, ठीक है। इस कैटेगरी में आते हैं रॉबर्ट हॉक, टेस्ला, ठीक है। सो आइंस्टाइन की basically just gave theories, right, which are getting proved right now. He gave a theory of relativity which is getting proved by this particular era because हमारे पास टेक्नोलॉजी अब एडवांस हो चुकी है. We have the advanced technology right now. Experimentalist was basically Galileo Galilei also, right? ठीक है. Can anyone tell me what did Galileo Galilei did in his lifetime? What did he discover? Yes, Maeve. Do you remember any experiment which Galileo Galilei did, and you have covered that in your content, or you have watched some scientific documentaries, so on and so forth?
No, not yet.
I cannot hear you, Maeve.
No, no, I don't know anything.
Still not audible.
I'm not sure about it.
Not sure. And we
Yeah.
have the new entrance over here, that is Azan. Azan, do you know who was Galileo Galilei? An experiment, famous experiment by him.
No, sir.
No, sir. Okay, we have no interest in physicists over here, right? So he discovered, you can, if you recall, the Lean Tower of Pisa experiment, right? Just search about it after the class, right? Lean Tower of Pisa. And he also proved that Earth was not the center of universe, solar system. ठीक है. Let me just quickly tell you the story of Galileo Galilei. Right? So before there was any telescope, before there was any technology, people used to think कि हमारा Earth is the center, right? And the sun used to rotate around the Earth, right? Sun and the moon, right? This was called heliocentrism, right? This was called heliocentrism. So we used to think that Earth is the center, and the sun and the moon and all the other planets used to rotate around the Earth, right? But what did Galileo Galilei did? He broke the entire basically convention, right? The beliefs of people. He invented telescope, right? He watched the stars, he watched the sun, he watched the moon with a telescope, right? So he experimented using a telescope, and he said that it is not heliocentrism. Sorry, let me just put the cross here. It is not heliocentrism. The solar system is basically geocentric, right? So what is geocentric, which we know till now, that sun is in the center, and all the other planets is at the basically rotating around the sun, right? We have Mercury over here, and then we have Venus, Earth. Let me just draw Earth over here, and so on, right? So he got basically a lifetime jail for this. Just imagine if you go to a group and you say, okay, let's say the Earth is going to die tomorrow. Okay, they will just grab you off and throw you into the water, right? So yeah, we don't want to change our views, right? That's what happened to Galileo. But we discovered when the technology advanced, we saw okay, he was true, and people gave life for the love of physics, right? Okay, now we are on Robert Hooke. So Robert Hooke was also an experimentalist. He basically did what? He changed the weights, right? He changed the weights and he observed what is the effect of changing force on extension, right? He observed the effect experimentally. What happens if we change the F on the extension, right? So he want to relate these two things, right? So what he investigated is as follows. That was done 350 years ago. He found out that the extension was proportional to the stretching force. Okay. Provided that the spring was not permanently stretched over here. So if I want to write this down using an equation, that is going to be as follows. That extension is proportional to force, right? It is saying if you increase the force, your extension is going to increase, right? So if I plot this graph, if you remember your basic high school mathematics class, if you want to draw direct proportional graphs, how do they look like? We have extension over here in centimeters. Let's say, let me just do meters. Your extension over here in meters, and you have force over here in Newton, right? If you have a direct proportional quantity, how would you sketch this graph? Would it be a straight line passing through origin, or would it be something else?
Straight line passing through origin.
Yeah, it will have a straight line passing through origin. And how do you read this graph? If you increase the extension, the force also increase. Or if you just like to see like this, if you increase the force applied, the extension also increases. Okay, if you decrease the force, likewise the extension also decreases, right? That is called a direct proportional relation, right? But we have interesting point over here. That is limit of proportionality, right? Now imagine if I just keep on repeating this experiment and I just do this. Okay, I put a very huge mass now. Okay, I put a very huge mass. Let's say m. Right now, if I remove this particular mass, let's say this was the original length of the spring. Right, your L is your original length of the spring. Original length, which was defined here. Right, this was the original length, which you can see. Now, if I remove this load, if I remove the mass, what happens? I see the spring is basically still like this, right? It is not going back to its original length, which was this, right? Which was this. So it means your spring is now destroyed. It has crossed the limit of proportionality, right? So what is the limit of proportionality is as follows, right? It is the point at which the load extension graph becomes non-linear, right? So after this particular point, there would be a certain point, let me call it A. After this graph, after this point, this would be like this. Okay, यहाँ तक it was linear. What does linear means? Linear means कि it's a straight line. Okay, this is a linear graph. And what does non-linear means? It basically is a curve, right? Or like this. Okay, this is a non-linear graph. This is a non-linear graph. Okay, I hope it makes sense. If it makes sense,
Yes,
if it is
sir.
clear till now, give me a thumbs up quickly. Okay, it makes sense to Varda. Just use the tools of Zoom quickly so I can get a feedback from you guys. Okay, it's clear to Mashal, Ryan, Ruba, Maeve, and to Azan also. Good. Okay. So we have this particular graph, right, which we have seen in the last slide. Okay, so we have some certain points over here which you need to analyze, right? So you have extension over here on the x-axis, right? This is called an x-axis if you want to relate with your mathematics class. This is called a y-axis. Okay, so on x-axis we have the extension that is in millimeters usually, and on the y-axis you have forces and force in Newton, right? You can see from point O till point E, right? The graph is a straight line. So this point is called the limit of proportionality. The limit of proportionality that is saying that the statement which Hooke made is as follows, right? Force is highly proportional to extension, right? So this is going to be followed under till this particular range, right? And if it crosses the limit of proportionality, this law is not followed, and you can see you can see what it becomes non-linear, right? Okay. And what happens to a spring after this? It basically is not able to spring is not able to regain its original shape, right? You might have played with a spring. Imagine just take a spring and extend it with a huge force, right? And try to leave the spring. It would not gain its original shape, right? And just try to extend the spring slowly, okay, till you reach the particular point. You will observe it experimentally also, right? The spring is not able to regain its original the original length, right? Okay. I hope the graph makes sense. And you can see after this particular point it crosses, it will not be able to regain its original shape, and this law will not be followed, right? So till this range, you have what? You have this condition true, that is f is proportional to the extension. Over here, you don't have this. Okay, it is not proportional to extension, right? It is not proportional to. Okay. So spring constant, right? Up, let's analyze the equation, right? What we have obtained till now, we have the following equation, which says k. Let me see the slides. Okay, I want Azan and Maeve to stay after the class for 10 minutes. I want to discuss about the content in the book, right? Okay. So we have 1 minute left in the meeting. I want you guys to rejoin with the same link as soon as possible, right? I'm ending the meeting right now. Everyone rejoin.
Yes, sir.
Okay. So I believe everyone is here. So let's start the discussion. So what do we have? Let me just sketch the graph again. So we have this particular graph, right, which we have seen. We have the extension over here in millimeters. And then we have the force over here in newtons. Imagine we have this particular graph and I'm not crossing the E point, which you see over here, right? I'm not crossing the limit of proportionality. I'm staying under it. So it's going to be a straight line here, right? This is point O. So what is the slope, right? We have this relation, right? We have this relation that f is proportional to extension. So if you recall your mathematics class, and if you want to remove a sign of proportionality to introduce a constant over here, right? So that constant is basically called K E, right? So this formula is called the Hooke's law, right? Hooke's law. And if you try to make K subject, you get us follow that K is F upon E, right? And this quantity is called the spring constant, right? This quantity is called the spring constant. Okay. So can anyone tell me, seeing this formula and this particular graph, how can we obtain, let's say if you have this particular graph, how can we find the value of K experimentally? Yes. Anyone? Give me a guess. A good one or a bad one. Yes. A guess. A quick guess. जल्दी से बताएं. Let me call the name. You want me to call the name? Okay. Yes. Azan. How do we get, if you just see this expression and let's imagine you have this particular graph in your end, how would you, let's say, find K from this graph? Azan, you're not
I
audible.
don't know. Yes, sir.
Azan, can you speak loudly?
Can you hear me?
It's not audible.
Hello.
Okay. Fix your mic. Anyone else? Yes, I am. Ryan, how do you get K? Okay, ठीक है, किसी को नहीं आ रहा, no worries. Let me insert a slide, a blank slide. Let me recall your basic mathematics concept. Let's say if you have x over here, if you have y over here, if you have a straight line, right? You have a point A over here, you have a point B, right? Your point A is basically x1, y1, and your point B is as follows, which is x2, y2, right? And how do we find the slope of this? This is changing
y2
by,
minus y1 upon
yes,
x2 minus x.
right. Okay. So we basically follow this formula which Hamza said right now. This is x1 comma y1. This is x2 comma y2. So if I want to find the slope, what is the slope by the way? It is basically stating k, that is basically change in y over change in x, right? So the quantity which is basically on y-axis, the change in that upon the quantity in x-axis, I want the change in that, right? That is equivalent to y2 minus y1 upon x2 minus x1, right? Similarly, see this over here. Imagine I gave you 2 points, point A, point B, right? And if you find the change over here, right? You want to find the slope. So how would you find the slope over here? That would be change in force upon change in extension, right? This is change in force, that is change in y, and this is change in extension, that is change in x, right? That is equivalent to force upon E, right? You compare the formula, it's same, right? So the slope of this force extension graph is going to give you the value of spring constant K. Does that
सर
make
ये
sense?
f इज इक्वल टू के ई में k क्या है?
Yes.
इज इक्वल टू के ई में k क्या है?
What is this? K is a spring constant, right? Make sense?
Yes.
Okay. So is this clear? How do we get K experimentally from the graph? If it is clear, give me a thumbs up so that I can move on. You have a question ahead and you which you want to solve. So make sure it is clear.
So could you
Maeve,
explain
you
it
have a
again?
question?
Yeah, could you just explain it again?
It's not audible.
Could you just explain it again?
Should I repeat that?
Yeah.
Okay, okay, okay. Sure. So is this clear? Is this clear?
Yeah.
Okay,
Yeah,
okay. Now
that's clear.
similarly, find this, see this thing over here. Okay. What do we have over here is as follows, right? We have, this is, let's imagine if I just plot the points over here, this is E1, right? This is F, right? Similarly, if I plot this particular point, this is E2, this is F2, right? So this will be the change in F, right? Delta F. So this change, this is basically delta F, right? Which was previously delta y, right? It is equivalent to delta y, change in y, because on y-axis I'm plotting forces. Similarly, this change is called as delta E, that was basically before delta x, because on x-axis I have now extension over here. So if you find the slope of this, that would be basically the force upon extension, right? And if you now, if you have seen this from, if you derive this formula of the slope, now if you try to see the formula actually from the Hooke's law, right, that says your spring constant is equivalent to force upon extension, right? This formula matches, right? So therefore, the slope of force against extension graph will give you the value of spring constant, right? And if you recall your mathematics class, if you take any other points on a straight line, your slope will be constant, right? So if you find a slope using point AC will be equal to if you find a slope using point AB, if you use let's say point BC to find the slope, you will have the same constant answer because it's a straight line, right? It's a straight line. Similarly, you can use any 2 points on a straight line over here to estimate the value of spring constant. Make sense?